Hi, my name is Sultan, and this is my presentation for task 4.1p. It's the second task, and I'm going to show you how I turned the whole big invoice table into a normalized ERD. And there are six steps. So let's start with the first step. The first thing I did was look for data that keeps repeating, which means a table is holding more than one data at a time. Invoice invoice 211347 shows up three times, and the sale data is the same in all three, and the product double A and ends with QW shows up twice, which is the same label and same price in both times. Vendor code 211 always has never fail next to it. So this one table is holding invoice data, product data, and vendor data all together. So this is a problem because if never fail changes its name, all those rows would need fixing, and missing even one of them would make the data wrong. This is called the update anatomy. And for step two, I had to find the primary key. This comes first because a partial dependency can only happen when the key is made of more than one attribute, but the inverse number by itself does not work because it repeats three times, and the product number by itself does not work either because it repeats twice. But when the two are put together, every record is unique. This works because of an assumption I wrote in my report. You'll see it in the. Mm, yeah, I wrote it somewhere around here. I'll show it later. The product is only listed once and on an invoice, so the primary key is INVNUM plus PRODNUM. Basically, invoice number plus prod number or produce number. And for the next step, I checked what every other attribute depends on, like the quantity sold only makes sense for the product on the invoice. So it needs both parts of the key. That is full dependency, and it is the orange arrows. Sale date belongs to the invoice, so it only needs the invoice number. Label, vendor code, and price all describe the product, so they only need the product number. Those only use half of the keys, so there are partial dependencies. Those are shown in blue. And the green arrow is transitive independence. No, sorry, the transitive dependency. Because the vendor name is different, it does not describe the product, it describes the vendor, and it comes from the vendor code, and the vendor code is not part of the key. And to get to the second normal form, I took out the partial dependencies. The rule is easy because anything that only needs part of the key gets its own table, and the part becomes the new primary key. So sale date went into an invoice table with the invoice number. The product details went into a product table with the product number, and the quantity sold stated with the full key. And the table was called line. The invoice number and product number stay in line as foreign keys, so nothing gets lost. And the invoice and the line are finished now, but the product still has vendor name inside it, so this is only in 2 and F. The third normal form fixes the transitive dependency. A vendor code gives us vendor name, and so I move both of them into a new vendor table where vendor code is the primary key. Vendor code stays in product as a foreign key, so the two tables are still connected. But now every attribute depends on the full key and its own table and nothing else. The vendor name is only stored once. That gives me four table: the invoice, product, line, and vendor. And for the final step, the last step was turning the four tables into entities and working out the query. A product can come from only one vendor, but a vendor can have like many products or no product at all. So the size is zero or many. But the invoice line is for one and only one product. A product can be many lines, but it can also be no line. What if like if nobody buys it? And at last, the line belongs to only one invoice, but an invoice has to have at least one line. So that side is one or many, but not zero or many. The line is there because one invoice can have many products and one product can be on many invoices, which is a many to many relationship, and it has to be split into one or many relationships. This primary key is the two foreign keys joined together. And these are the six steps. So, in summary, a large table became four smaller tables, and the sale date is stored on invoices, and the product details once per product, and the vendor name once per vendor, which gets rid of the update, insertion, and deletion. All the four tables are now in 1NF, 2NF, and 3NF, and the ERD shows the thing the dependency diagrams cannot show. That is a relationship and its cardinality. So, thank you for watching.